Today we are going to discuss the topic about synchronous induction motor. The application of high starting torque and constant speed application in synchronous induction motor can be used. The advantages of both synchronous and induction motor is the synchronous motor gives constant speed application. Then the normal slip induction motor having three-phase winding on the rotor circuit. The motor is connected to the exciter which gives DC supply to the rotor through the slip rings. One phase carries full load DC current while other two carries half of the full load DC current as the parallel. A three-phase slip ring induction motor runs constant speed when rotor winding is used from the DC source. Such motor is called synchronous induction motor. Consider normal three-phase slip ring induction motor, conventional three-phase rotor. A DC supply is fed to the rotor winding. Due to this alternate north pole and south pole of the rotor carries alternating current working as induction motor. DC excitation is also fixed in the space and does not shift as the when rotor carries alternating current. The fixed rotor poles get magnetically locked with the rotating magnetic field produced by the three-phase stator winding, carrying alternating currents, and rotor runs constant speed applications. This is the circuit diagram of synchronous induction motor. The synchronous three-phase supply is fed to the motor and slip ring is connected to the starting resistance. Then as well as motor is as well as sap connection of exciter circuits. The machine started as ordinary slip ring induction motor and additional resistance inserted in the rotor circuit. Additional resistance inserted in the rotor circuit. The run position connected to the exciter rotor winding is rotated. It may be possible that AC winding put the rotor and DC excitation provided on the stator. This simplifies the control gear. It gives better facility and insulation which permit higher voltage and lower DC excitation. The DC winding must be designed such a way as a high MMF with moderate DC excitation power. The excitation loss must be distributed even over winding. The MMF distribution should nearly sinusoidal. It should also provide damping against hunting and it should satisfactorily started as induction motor. When the machine running as induction motor, there are induced alternating current of the rotor and it's run below synchronous speed. When the rotor carries DC current, the rotor field hence rotor must run at synchronous speed. This means that slip must be reduced to zero. But if there is any departure from speed during normal operating against induced current. This is the waveform of synchronous induction motor and angle between the synchronous induction motor explanation. Then advantage. The synchronous induction motor can start and synchronize again more than full load torque which not possible the salient pole synchronous motor and it is useful for light load application. The exciter required for synchronous induction motor is smaller capacity. Then the rotor winding of synchronous induction motor can providing excitation and required damping. So separate damper winding is required. Disadvantage of synchronous induction motor. First of all, here the gap is small compared to normal salient pole synchronous motor. So that large overload capacity. The variation of power factor is large compared to normal synchronous motor. The speed variation is not possible for synchronous induction motor, runs at constant motor. Application. The application of synchronous induction motor will be used for application oriented in remaining nearly constant. This motor can be used. Thank you.